probabilities using combinations, sometimes we do have to do these. If we're dealing a 3-card hand from a standard deck of cards, what is the probability that the hand contains, first, all red cards? Okay. Oh, all right. Okay, so anytime we do probability, on the bottom is going to be our total number. So we're dealing a 3-card hand. Let's say you're given, an ace, a king, and a queen. That might be a nice hand. Well, let's say instead of in that order, someone gives you a king, an ace, and then a queen. We were given the cards in a different order, but does that count as a different card of hands? So because the order does not matter on this, we are going to use combinations. So for the bottom, what are all the possible ways that we can have a 3-card hand? There are 52 total cards, and we're going to choose to have 3 of them in our hand. So that gets us our total number of ways to have 3-card hands. So now the fact that we want them all to be red, we ask ourselves how many red cards are in a deck of cards, and there are 26 red cards. And of those 26, we want all 3 of our cards to be red. So now we just have to figure this out. Now I might kind of separate it and look at our numerator first. 26 choose 3 is 26 times 25 times 24 over 3 times 2 times 1. 3 times 2 is 6, which goes into 24 4 times. So 25 times 4 is 100, and 100 times 26 is 2600. Now I might look at, actually scratch that. I'm going to leave that, I'll tell you why in a second. I'm going to leave that as 26 times 25 times 24. Or times 4. Okay, now our denominator, we have 52 choose 3. So 52 times 51 times 50 over 3 times 2 times 1. So 3 goes into 51 17 times, and 2 goes into 50 25 times. So I'm going to leave this as 52 times 17 times 25. So if I leave these broken down like this, it actually will help me get a reduced fraction. So we're looking at, here's our numerator, 26 times 25 times 4 over 52 times 17 times 7 times 25. So now if we can do any reducing between the top and the bottom, well, these 25s are going to cancel out right away. And now 52, well, I know 4 goes into 52 13 times. And we have 26, 26 and 13 will reduce because 13 goes into 26 twice. And we are left with just a 2 over a 17. And that's reduced. How nice is that? So 2 divided by 17 gives us a decimal of 0.118. But if we need a reduced fraction, keeping it separate helped out on that. So now what's the probability that we have 1 face card and 2 aces? We're going to use that same 52 choose 3 because we still have that 3-card hand on the bottom. On the top, though, how do we get 1 face card and 2 aces? So if we look at our face card, we have 12 face cards to choose from, and we want just 1 of those. At the same time, we want 2 aces. There are 4 aces to choose from, and we want to choose 2 of those. We're going to multiply these together because we want these at the same time. So 12 choose 1 is just a 12 times 4 choose 2 is 4 times 3 over 2 times 1. So that reduces to, we have 2 times 3, which is 6, 6 times 12, which is 72, over, now hopefully this won't be too weird, this 52 choose 3, since I already did the work, I'm going to go ahead and just grab those numbers. It's going to be over 52 times 17 times 25. And actually, I keep changing on you, I'm going to leave this as 12 times 2 times 3 because working with these smaller numbers, it may just be easier to reduce. So I know that 2 goes into 52 26 times, and 26 and 12 can both go down by 2, so 6 and 13. And I think that might be it. So we just multiply top over the bottom. I'm running out of time.